Alright, hello everyone. So let's learn about double angle identities. Now to learn about them, let's compare them with Pythagorean identities. So sine square x is 1 minus cosine square x. Cosine square x is 1 minus sine square x. Now double angle identities, when we compare, one thing to notice is that Pythagorean identities always switch between sine and cosine. When you have sine, it gives you the opposite function cosine. Sine square gives you cosine. Cosine square gives you sine. But double angle identities here, yes, when you have sine square you get cosine, but when you have cosine square it gives you back cosine again. So every time it does not switch between sine and cosine. So one thing to remember. The other thing is, if you look at Pythagorean identities, the angle value doesn't change. What do I mean? Here we have sine square x and it gives you back cosine square x. So x didn't change. X is the angle, right? Think about it. You take sine and cosine of an angle. So the angle didn't change. But in double angle identities, the angle value get doubled. Whatever you have here x, it becomes 2x, it becomes double. That is why it called double angle identities. When you have cosine square x, it gives you back cosine square 2x. Now what do I mean? You will be like, okay, that's obvious. Now here's something you can do. Maybe you don't know this. You know, let's write double angle identities again. Sine square x is 1 minus cosine 2x. So this is the identity. How about sine square 2x? Now remember, whatever you have here, it get double. So what is this? 1 minus cosine, guess what? Yes, 4x over 2. So that's very important. It double the angle value. Let's say you have cosine square 4x here. So this will be like 1 plus cosine what? 4x times 2, 8x over 2. Yes. Okay, only this inside angle value change, nothing else change. Okay, the angle value doubles. So sine square 3x, let's quickly, oops, not sine cube, sine square 3x is 1 minus cosine 6x over 2. Okay, alright, so that's one thing about double angle identity. It is double the angle value. The other thing is, if you compare this then with Pythagorean identities, remember I said in Pythagorean identities, the power doesn't change. Always you have a square. Alright, you change between squares. You change only the trigonometric function. The power remains unchanged. Now in double angle identities, as you can see, this square gets to the power 1. So the power reduce. It gives you, so you have a sine square, it gives you back a trigonometric function with power 1. You have cosine square, it gives you a trigonometric function with power 1. I think that is the most important thing about double angle identities in the context of trigonometric integration. Okay, it reduces the power. Alright, so let me tell you why this is important. Let us do some exercise. So let's say you have sine 4x. Okay, sine to the power 4x. Okay, now think about this function. Now let's say you want to integrate this function. So I will try to tell you the bigger picture. Now if you want to integrate sine to the 4x, it's very hard. Any trigonometric function with a power greater than 1, it's very hard to integrate. But versus, can you integrate sine easily? Sine x, of course yes. Can you integrate sine 2x easily? Of course yes. We know that we can't integrate sine to the 4x and write sine to the 5x over 5. We can't do that, right? We can do that for x to the power 4, but not for the trigonometric function. Now what double angle identities does is that, okay, before integration, okay, you have a trigonometric function with a power greater than 1. Now I will reduce it to a power 1. That's what double angle identities does. Okay, then you can do the integration easily. Okay, so now in this video, let's only learn how to use double angle identity to reduce the power. So let me show you. So here we have to use the identity sine square x 1 minus cosine 2x over 2 because we have sine. So this is the relevant double angle identity. but we have sine 4, sine to the power 4. So how do we cope up with that? Well, sine to the power 4 is sine square x to the power square. So that means this is to the power square, right? So sine 4x is 1 minus cosine 2x over 2 to the square. Understand that correctly. Now you can't write this as 1 minus cosine to the power 4x. That's wrong, okay? Power cannot change. You can't input or change, play with the power like that. If you have sine to the power 4, it has to be everything to the power square, okay? Only your angle value can be doubled, okay? Alright, so now how can we change this one? Well, this is 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2, right? That is the meaning of this square. You multiply it by itself. Okay, so now denominator 2 times 2 is 4. So here 1 minus cosine 2x, 1 minus cosine 2x. Okay, alright. Now let's FOIL the numerator. So 1 times 1 is 1. 1 times negative cosine 2x is negative cosine 2x. Negative cosine 2x times 1 is negative cosine 2x. And negative cosine 2x times negative cosine 2x is positive cosine square 2x. Okay, over 4. Alright, now you will be like, well, our purpose was to reduce the power, but still we have a power of 2. How can we get rid of that? We want power 1. Now what can we do here? So let's simplify this furthermore. This is 1 minus negative cosine 2x minus negative cosine 2x, negative 2 cosine 2x plus cosine square 2x. Now you have to learn these tricks. Okay, let's divide each term in the numerator by 4. Okay, so this is 1 over 4. Negative 2 cosine 2x over 4 is cosine 2x over 2. 2 and 4 cancel out, plus cosine square 2x over 4. Okay, what can we do here? Well, my goal is to rewrite this function as a power 1. Then what identity you should use? Double angle identities again. Don't use Pythagorean identity here, because understand this. What is our end goal? End goal is to write a trigonometric function in just power 1. Can Pythagorean identity ever do that? No, okay? Pythagorean identity always work with squares. It never reduce the power. So we have to use double angle identities for this part again, okay? So we know double angle identity cosine square x is 1 plus cosine 2x over 2. So if you have cosine square 2x, so if you have 2x here, so this is 4x, right? Double the angle value. So let's replace that here. 1 over 4 minus cosine 2x over 4 plus cosine square 2x is 1 plus cosine 4x over 2 divided by 4. Okay, alright, so we are almost done. 1 over 4 here minus cosine 2x over 4. This part will be like 1 plus cosine 4x over 2. Division by 4 is reciprocal multiplication of 1 over 4. So 1 plus cosine 4x over 4. 2 times 4 is 8. Okay, so look at the result. It contains only cosine functions with power 1. So we change sine to the 4x into a cosine functions of power 1. Importantly, power 1. Okay, alright, so let's do another example. So let's do cosine 4 through x. So be with me, try to learn how to do this. Now we want to write this function as in terms of trigonometric functions of power 1. Okay, so here cosine, we have to use double angle identities. So cosine x is 1 plus cosine 2x over 2. Okay, so now we have cosine 3x here, right? So cosine square 3x, my bad, I'm sorry. Cosine 3x is 3x get double, so it's cosine 6x. Okay, now here we have cosine square. How do we get cosine to the power 4? Well, we square it, right? So this is cosine to the power 4 3x is actually 1 plus cosine 6x, similar to previous problem. Now here what you can do is go ahead and pause the video and try to do it by yourself and compare with my answer. So this is same as 1 plus cosine 6x over 2 times 1 plus cosine 6x over 2. I'm gonna do this fast. So in the denominator it's 4, in the numerator it's 1 plus cosine 6x times 1 plus cosine 6x. Now you FOIL it, so what we get is 1 plus. Now I will do the FOILing fast. Okay, so it will give you 2 cosine 6x plus cosine square 6x. Okay, so I skipped a step. Try to do the FOILing by yourself step by step. Do it slowly. Okay, after simplification this is what you should get. Okay, again remember we didn't fulfill our purpose because we have a trigonometric function to the power 2. We want it to write it in terms of power 1. Now let's simplify furthermore. Let me divide each term in the numerator by 4. So it's 1 over 4. It's cosine 6x over 2. 2 and 4 cancel out, plus cosine square 6x over 4 here. Now cosine square x is 1 plus cosine 2x over 2. Now cosine square 6x is double of 6x is 1 plus cosine 12x over 2. So let's replace this right in here. Okay, so this is 1 over 4 plus cosine 6x over 2 plus cosine square 6x is 1 plus cosine 12x over 2 divided by 4. So this is what we get, right? Okay, here we know the reciprocal. Here we have to divide by 4. So division is reciprocal multiplication of 4. Reciprocal of 4 is 1 over 4. So this is 1 over 4 plus cosine 6x over 2. 1 over 4 plus 2 is 8. 1 plus cosine 12x over 8. See, now the result is only contains trigonometric functions of power 1. Okay, so cosine to the 4 3x now reduced to cosine functions of power 1. That's how we use double angle identities. Okay, all right, so now I think we are prepared to learn trigonometric integration. So hopefully you guys stick around. I will catch you in the next video. Thank you very much for watching this video. Bye bye.